Welcome to the last video on notes for Chapter 7. This video will cover the notes in Chapter 7.3. So you'll need your textbook and we'll be on page 345 to begin with. I actually think this chapter makes a whole lot more sense if worked backwards. So while you're getting your textbook out, I'm going to go ahead and give you a little bit of a demonstration on the main concept that drives this chapter. Let's say that you have a triangle, kind of like this one. I'm going to zoom out so you can see it a little better. So if we have a triangle, much like this one, what Chapter 7.3 or Module 7.3 explores is the relationship between opposite sides and opposite angles in a triangle. So we have this angle up here, and just for the sake of having a name, I'm going to call this angle A, and I'm going to call this one angle B, and I'm going to call this one angle C. So in this triangle, if we adjust the opening at angle A, if we make angle A really, really acute, then we can see what happens is in order for this triangle to be still complete, right, still a triangle, then this side over here between B and C has to get shorter and shorter and shorter, right? For my whole triangle to be a triangle, let's pretend this part has fallen off. This would be a really, really short side if this angle is really, really small. Let's do the opposite. Let's open this up and make it a really wide angle, a very obtuse one, and watch what happens to this side. The more and more obtuse I make angle A, the longer this white edge has to be in order for the triangle to be complete. So what we're seeing is that there is a relationship between the opposite sides and angles in a triangle. Opposite angles and opposite sides can be identified by looking to see which side or which sides make this angle. The green side and the blue side make up angle A. So the opposite side is the white side, the side that does not meet at A. If I wanted to know what angle was opposite of this blue side, the angles on the ends are A and C, so B must be the opposite angle. It's the only one that doesn't actually touch the blue side. So once again, if we were to open this all the way, you could see that I've even run out of white paper down here. But that's okay. The concept still exists. As long as we continue stretching out this angle and making it more and more obtuse, the longer and longer and longer this side has to be. The shorter we make this angle, the smaller we make this angle, the shorter the side has to be until you just barely have any side left at all. So opposite sides and angles have a relationship. Wide angles make long sides, and acute, narrow angles make short sides. And that's really what this entire chapter is about. So with that knowledge in hand, we're going to take page 345. And yes, this is like the end of the chapter, but as I said, I feel like this chapter makes more sense if you work it backwards. And we are going to order, I'm sorry, not 345. Go to 347. We're going to order the sides and the angles based on this knowledge that we just gained from that little demonstration. So we're going to start with numbers 13 and 14. Like I said, we're working backwards. So on number 14, this is, of course, a 90-degree angle. And our instructions say to order the side lengths from least to greatest. So I want my smallest, and then my middle, and then my largest. Our smallest side is going to be across from our smallest angle. So let's find our smallest angle. It's 30. Well, 30 degrees is made up from where this line and this line connect. So the opposite side must be AC. AC is our smallest side. Our middle side is going to be across from our middle angle. So 30, 60, 90, 60 is pretty clearly in the middle of that. Angle A, which is 60 degrees, is made up from the two lines AC and AB. So the one that does not touch the actual corner is this green line, and that's the one that's opposite from angle A. So side BC is opposite from angle A, and since this is the middle angle in terms of size, this is the middle side in terms of size. So lastly, we're left with our 90-degree angle. Our 90-degree angle is the largest. It is made up of AC and BC meeting. So the side that does not touch this corner all the way across the triangle here is side AB. So AB is going to be our largest side in this triangle. Let's do that again with number 13. For each triangle, order the side lengths from least to greatest. This time I'm going to be a little bit more intentional about my color coding. I'm going to pick one side and second side and a third side, and I'm going to color code them right from the beginning. That way we can color code our angles to match. And this will really be a little bit of a better example than this one. So for each triangle, it says order the side lengths from least to greatest. So again, that is smallest, and then the middle, and then the largest. So I am looking for my smallest angle. Well, if you're looking at this triangle, you pretty clearly can tell that this is a super tiny angle, 5 degrees. So this angle up here, 5 degrees, is across from or opposite from side CB. So CB is the shortest side because it is across from the smallest angle. Our middle side is going to be across from our middle angle. Well, if our only two remaining options are 60 and 15, the next smallest is going to be 15. So 15 is across our triangle from this purple line, AC, which means AC is our middle side. If you're struggling to see how AC is across from B, if it's the farthest side away, just remember to look and see what lines are connected at angle B. The pink line and the orange line are connected at B, so they cannot be the opposite side. The only one remaining that doesn't connect here will be the opposite, and so that's going to be AC. So lastly, if we've done the first two correctly, we should have the longest side left. Our longest side, AB, should be across from our longest angle, which is 160. 160 is significantly larger than 5 and 15, so we know that we have done this correctly. Right above that, we're doing the same thing, but instead of knowing the, oh no, actually that is 100% the same thing. I need to slide over to page 346. We're doing the same thing, but now we are ordering the angles after being given the sides. So for angle, let's start with B. For our longest side length, that's going to be across from our greatest angle measure. So I'm going to color code both of these in orange this time. Our longest side length of 20, 21, and 22 has to be 22. And the angle across from that is the one that doesn't touch this orange line at all. C touches, B touches, so angle A is our greatest angle measure. Our longest side is CB, which is 22 units. Our largest angle is A, and we know that even though we don't know what it actually measures. Our shortest side length and our shortest angle measure are going to be across from each other as well. So our shortest side is 20. It connects A and B. If it touches A and it touches B, then C must be the angle that is opposite, and C is going to be the smallest angle. So AB at 20 units is the smallest in this triangle. And so to fill in the blank, to order from least to greatest, our least was angle C. Our greatest was A, so that must mean that B is our middle. Let's slide a little farther down the page and do some more examples on our own. For each triangle, order its angle measures from least to greatest. Now, it could at any point swap from greatest to least, so don't get in the habit of thinking that we're always going to do least to greatest. So the smallest, the middle, and the largest on both of these, just like we've been doing. And we can kind of color code if we want. So for each triangle, order its angle measures from least to greatest. So I am looking for my smallest side first, and that's going to be 15 over here. Well, if this line connects angle B and angle C, our smallest angle is going to be angle A. We want the angle that is opposite from this side. On our middle side and angle pair, our middle side is 32, which connects C and A. If the side touches C and it touches A, then its opposite angle has to be angle B. So that leaves our last side, which is 40 and the longest. That side touches angle B and it touches angle A, so C is the one not being touched. It is the opposite angle, and therefore it is the largest. Okay, last example, number 12. Our smallest side is 7. The angle across from that is angle B. Angle B is the smallest. Our middle side is 24. The angle that doesn't touch this side and is therefore across or opposite is C. Finally, our 25 is our largest side, and it needs to be across from our largest angle, which is angle A. And once again, we know that because angle A does not touch this side. This side ends with angle C and angle B, so the one that's not used is the one opposite.